Our next topic is about arithmetic progression. So arithmetic progression is a number series for which each term, except the first, can be obtained by adding a constant to the preceding term. An arithmetic progression is sometimes called an arithmetic sequence. So the numbers below, 3, 7, 11, 15, 19, 23, 27, and 31 form an arithmetic progression because, as you can see, the numbers are obtained by adding 4 to the preceding term. So what are the formulas for arithmetic progression? So number 1, we have the common difference. So the common difference D is the number added to obtain the next number. So this is given by the formula succeeding term minus the preceding term. So for example, in this number series, the common difference is equal to 4, and we can check it by subtracting any two adjacent terms. So if you check, 19 minus 15 equal to 4, 15 minus 11 equal to 4. A sub n is any n term, and this is any number or term in the progression. So if the first term a sub 1 is given, so the n term a sub n equal to a sub 1 plus n minus 1 times d. If the first term is not given, but there is any mth term in the progression, so the nth term a sub n can be expressed as a sub m plus n minus m times d. Arithmetic mean is the average of a set of numbers. So for two numbers, x and y, the arithmetic mean is the number in between them. And the arithmetic mean of two numbers, x and y, is x plus y over 2. For a set of numbers, x1, x sub 2, x sub 3, and so on until we have x sub n, the arithmetic mean is simply obtained by adding them and divided by the number of the terms. Arithmetic means are the terms in between any two terms of an AP. So, example, in this number series, if we have 7, 11, 15, 19, and 23, so 11, 15, and 19 are arithmetic means between 7 and 23. Then we have the sum formula for an arithmetic progression. So, S equal to n over 2 times a sub 1 plus a sub n, where a sub 1 is the first term, a sub n is the last term, and n is the number of terms. We can also express S in terms of n, a sub 1, and the common difference d, and that is given by this formula. So to illustrate, we have the succeeding problems. Find x so that x minus 2, 2x plus 2, 9x plus 3 form an arithmetic progression. What is the common difference? So, the three expressions here form an arithmetic progression. So, to solve for x, we can use the common difference. So, the common difference is obtained by subtracting any adjacent terms. So we have here 2x plus 2 minus x minus 2. And that is also equal to 9x plus 3 minus 2x plus 2. And from this, we can solve for the value of x equal to 0.5. So to answer the question, what is the common difference? We will simply substitute the value x to the 2 or the difference between two expressions here. So 2x plus 2 minus x minus 2. So when x is 0.5, we obtain the common difference d equal to 9/2. Next problem. There are 4 arithmetic means between 8 and 128. Find the 10th term. So if we show the numbers, so we have here the first term is 8, and then the last term is 128. And in between them, we have 4 arithmetic means. So, meaning, there are 6 terms all in all, with the first term a sub 1 equal to 8 and a sub 6 equal to 128. So, the question is the 10th term, so we can solve first the common difference by using the n-term formula. So, a sub n equal to a1 plus n minus 1 times d. So, substituting values, we can solve for d equal to 24. Okay? So, the 6th term is 128. The first term is 8. Then we have 6 minus 1 times d. So, d equal to 24. So, we can now solve for the 10th term using the same formula. So, we have n term is equal to a1 plus n minus 1 times d. So, we have now the 10th term equal to the first term plus 10 minus 1 times d, which is 24, and it will give us 224. Next problem. Rolls of carpet are stacked in layers so that the top layer has 3 rolls and each lower layer has 1 roll than the layer above it. If there are 21 rolls at the bottom, how many rolls of carpet are there in all? Okay? So, if we draw the stack of carpet, so we have here 3 rolls at the top, then in the succeeding lower layer, it is 1 more than the number of rolls on top. So we have 3, 4, 5, and so on. And then the last layer, which is at the bottom, has 21 rolls. So the question, how many rolls of carpet are there in all? So we will compute for the sum. And we have here the first term a1. We have here the last term 21. But we do not know how many layers are there. So from the number, or we can solve for the number of layers by using the first term and the last term here. So applying the formula for a sub n, so this is 21 equal to 3 plus n minus 1 times d, which is equal to 1, and n is equal to 19. And we can substitute the formula for the sum. Then we have 228. Next problem. 3 brothers, Art, Bert, and Charles, divided a gift from their father, an amount of 48,000. Bert's share is twice that of Art. Their shares in the same order form an arithmetic progression. How much is Charles' share? So, if we add the 3 shares, that will total to 48,000. So we have that here. So let A equal to Art's share, B Bert's share, and C Charles' share. So if we add, that is equal to 48,000. Then we have Bert's share is twice that of Art. So we have B equal to 2A. Or we have 2A equal to minus 2A minus B equal to 0. Then their shares in the same order form an arithmetic progression. So we can use the common difference formula. So that is B minus A is equal to C minus B. And from this, we can obtain this equation. So we have 3 equations containing 3 unknowns, A, B, and C. So by calculator, we can solve it. And the value of C, which is Charles' share, is equal to 30,000. Next problem. Find the sum of the positive integers divisible by 3 from 52 to 110. Okay. So from 52, the first number divisible by 3 is 54. So I will call it the first term. And up to 110, the last number less than 110 that is divisible by 3 is 108. So we can solve for the number of terms in between 52 and 110 that is divisible by 3. So, the common difference of the numbers is 3 because if the numbers are divisible by 3, meaning the difference between them is 3. So, we have now 108 is equal to 54 plus n minus 1 times 3, and n is equal to 19. So, if we will solve for the sum, we can use the formula for the sum and obtain 1,539.